All right, we're back. We are COMP123 in the summer 2017 semester, and it's week 11, part 3 of our class, right, of our broadcast. And we're talking about the card game simulation again today. This is the last time I think we'll do it in this particular way. We might reintroduce this in the interface, user interface stuff that we're going to be talking about next week. I was hoping to start user interfaces this week, but this became a little bit more detailed. And so what I want to do is I want to go back and talk about classes very briefly, and then I'll talk about some of the stuff that's up. And that starts off around way back down here. So what I'm going to be doing today is talking about collections, specifically the list collection, a little bit more detail, right, briefly. And then we're going to get right into modifying our project from last day. And you have a lab 25 that's up right now that I put up on eCentennial. It's due tonight at midnight. It's worth 0.5% of your final grade, right? So 0.5%. And it has to do with what we're going to be doing today. Okay, so we're going to continue from 11B, the last class, so you can use that as a base. So what are collections? We talked about collections are a group of related objects. And how are they similar to arrays? Well, arrays, basically are references, and so are collections. Okay, that's the one thing you need to know. The other thing is, how are they different? Well, collections are classes, and arrays are like structs. They're structures, right? So they're not classes. Arrays are fixed, and collections are variable. But one thing I want you to think about is this. A collection, for the most part, on the front end, is an abstraction of array on the back end. So the way C# creates a collection is it creates one or more arrays that it shuffles around and does its magic. It has its own methods. And then it looks like the functionality is like a collection, right? But it's really an array in the background. What does that mean? A collection is always slower than an array, right? Because a collection is an array, but it's a special type of array, okay? Or a group of arrays. Okay, so I want you to think of that. So that's what a collection is like. Okay, let's take a look at this. So there's different kinds of collections. We talked about the list primarily, and we're going to be continually talking about that. There's also another thing called sorted list with key and value pairs that you can use. Sometimes this is more effective. There's a couple of other collections that you'll see in programming 3, hopefully. The queue and the stack. A queue is like a lineup. So if you line up for a bank, it's a queue. And it has a first come, first served kind of method, like first in, first out. Right? That's the methodology when it comes to adding and removing elements from the array or from the list, right? It's still a kind of list. It's a special kind of list, special kind of collection, all right? And a stack is similar to a queue, but it's like first in, last out, okay? First in, last out, all right? So first in, first out, first in, last out. So I can pop stuff off the stack, right? Think about a stack. We use stacks for memory management typically. There is a stack that we use in C# as well. And if you haven't heard about it, we're going to do more with queues and stacks in programming 3. All right, so let's take a look at the list collection. Again, it's a generic. We talked about this and how you declare it. The T stands for the type. And we created our own type, a card list, right? We have a problem. We do have a problem. And we have to solve this problem because I want to create a new class that's similar to the deck. And once I start talking like that, then it seems like we missed something. And we did. We'll go back and fix that. A list has a bunch of methods and properties. Here's some methods, right? So there's the add range. Add basically adds a member to the list. It adds it to the next element in the list, typically. Capacity checks to see how much capacity the list has, right? And usually what happens is as the list increases in capacity, it doubles. So a list is always, the capacity of the list is always sets of 2. So what does that mean? That when I add one element, the capacity is 2. When I add 2 elements, the capacity is 2. If I add 3 elements, the capacity is 4. If I add 4 elements, the capacity is 4. If I add 5 elements, the capacity is 10. Or 8, sorry, 8. And it'll keep doing that. It'll keep doubling, doubling, doubling. Why is that bad? Means you have double the amount of memory sometimes, right? And so that could be an issue. And that's why sometimes what we want to do with capacity is manage it by specifying the capacity of a list ahead of time, right? If we know, for example, we only need 52 cards, then I can specify a list of a capacity of 52. But if you're playing Magic or Pokemon, as an example, that's a different kind of deck, right? Maybe the maximum capacity is 60, right? And that's all you would have. All right, so then we have our clear, which removes all elements from the list. This is really important. So one command. And what does remove do? Does it actually remove really anything? Yes, it does. But what it really does is dereference everything. So basically all the elements, all the data that we had in that list, it's quote unquote lost, right? We don't know where it is. It's gone. It's in volatile memory now. And we don't have to care about it anymore. Right? So that's what clear does. Contains really checks to see if the list contains a value, and we can check to see what the list contains. We can use that, but it only returns true if it's contained in the list, right? It doesn't return the actual item itself. Okay. Here's the next one. If it contains, let me go back up here. If it's contained, we can use index of to get the index of, the item that we're looking for. Now that is better, far better, right, than what we did with the Villing superclass, right? But I couldn't introduce this because we're going to be talking about collections today, right, and yesterday, or on Tuesday. So that's why I introduced it. I wanted to show you, if you didn't know how to use a list, how would you do it? I showed you how to do it. And it was a very poor way of doing it. All right, count, of course, is a property. It's not a method, a property that basically counts up the elements of the list. Okay, but this is an active property. So whenever you use it, think about it recounting the list every time. Okay, so if the list changes, the property method changes. The count property changes. All right, and then of course you have some other ones. Inserts at a specific place in the list, and what it does when you insert is it pushes the list other elements down. If you insert at the top, it pushes the entire list down. And think about that kind of array operation. If you're going to do this with arrays, I would create a new array, brand new, add the element at the top, and then read everything from the old array and copy it into the new array, right? That's what it's really doing in the background when you do insert. Okay. What about if I'm inserting in the middle? So I have some stuff in the top. I'm going to insert in a certain position. So I take the stuff in the top, copy it to the array, take my new insert, copy it to the array, take the stuff from the bottom of the list below where I'm inserting, take that, copy it to the array. So I'm doing like 3 copy operations to make this insert happen. Potentially, right? Now, it happens in the background for you guys, right? When you do an insert. Same thing, remove. I look for the first occurrence of a specified value, right? Wherever that is in the list, and then I remove it, and then I reorder my list again, right? And all that happens in the background. You don't have to worry about it, but it's still happening. It takes cycles, computational cycles in the background to make that happen, okay? Remove that, specifies where, it doesn't matter what the value is, you just tell it which index you want to remove. We're going to use that one today, right? Remove range takes a special range from one index to another and removes all those elements. Sort is very expensive, but what it does is it sorts the list alphabetically. And sometimes we want to do that in specified lists, right? I'm not going to talk about trim excess. But those are the most common methods and properties that you'll see for lists, right? And I've given them here for you so that we're going to reuse them, right? When it comes to user interfaces. When I build user interfaces with Windows forms, we're going to see that we're going to make a list box, and the list box is going to return a list, right? Which is going to use all these methods. You're going to see these methods come up again. All right. Other things to note, this is just talking about this, the capacity, right? One thing it says is that when the list is created, both the capacity and the count are 0, but as the list grows, it doubles in size, right? So let's take a look at this. Here's before adding the items to the list. Let's see if you can help me out here. Items count. I just created the list. How many items are in the list right now? 0, right? When I create a list for the first time, it's just a container. It's empty, right? Now, this didn't make any sense for our deck list, our deck container, right? Our deck should always have cards, right? And if you look and see what a deck is, I just want to kind of specify this so we're not confused here. So if I look at a deck of cards, right? If I look and see what that is, just to give you an image, because some people don't know what that is. They've never seen a deck of cards in their life. It's just cultural, right? This is what a deck of cards could look like, right? It has a bunch of cards, right? All stacked together. You could also argue, hey, Tom, why didn't you use a stack instead of a list? Because a stack is more, from an analog to a card deck, a deck of cards, than, let's say, for example, a list. And the answer is, yeah, you're right. I could have. And lists are more common, so that's why I use the list. The other thing is that if I have a hand, here's a hand, 1, 2, 3, 4, 5 cards, right? Here's a hand. It has cards, but it's not a deck. A deck is a list of cards. A hand is a list of cards. But both have different properties. One, the deck has the shuffle method. Can I shuffle my cards in my hand? Typically not. I don't want to shuffle them. And the other thing is, can my hands be empty? Yeah. Before I'm dealt the cards, my hand is empty. So I can create an empty hand card list, and my deck can't really be empty in my head. It doesn't make sense, right? But what I'm talking about is two different structures that use very similar properties. And this is our problem from last day, right? We made one structure, but I need another one. Can I inherit my hand from my deck? No, that doesn't make any sense. Hand doesn't come from deck. Hands come from body, right? It doesn't make any sense. Analogy is, the analogy doesn't fly, right? However, is deck a card list? Yes, it is. Is hand a card list? Yes, it is. Which means that we may have to refactor our program to create a superclass that both can inherit from. All right? So we're going to do that today. But going back to this, the idea of this deck of cards, right? So yes, in this particular case, this string list is empty. So the count will be 0. What's the capacity? Right. Nothing. Right? There's nothing in there. Right? Okay, let's keep going. So here we go. We added a red card, right? A red, and we insert at 0 yellow. So yellow now is at 0. Red has been pushed down to 1. That's what's happening there, right? And then what's our count now? 2, right? What's our capacity? 2, right? Is it? We'll see. And then we iterate through our stuff. We print out the items that are inside of our list and so on. And then, right, we add a couple more. We add a couple more, right? And we go, I'm just going to keep going. And we add a green and a yellow. Yay! What's our count now? 4. What's our capacity? Is it? Let's see. And then we remove 1, right? We remove the first yellow occurrence, which is where? Probably at the top of the list, right? Notice that we're removing a value. We're not removing at a position. That's a different kind of method, right? So remove searches for something that's in the list and removes it. Hey, hold on. How can I remove a card? Can I remove a card? Card's not a string. A card is a card, a different object. That means I got to search for it somehow, which means I have to be able to compare it somehow, which means I have to implement iComparable, which means, if I wanted to use the remove method, right? So I got to think about that when it comes to using methods. Some of them may not work the way you think about it when you use custom objects. On a string, no problem. It's a built-in object, so we know how to compare a string to another string. But if I don't, I need to implement iComparable, which we talked about before. Am I going to do that today? No. All right, but here this will work for us because this doesn't care what the value is, right? This removes whatever object is at 1, at the second position. The 0th position is the first position. The 1th position is the 1. That's what it means, right? 0th and the 1st. Okay, and we've done some moving around, and it says now the deck contains. It checks to see if red is contained in the deck. Notice that I'm using a ternary operator with a question mark and a colon. It's this. The way it works is this. Think about this console write line. Let's read it together. So a new line. It says red is, and then it checks to see if red is in the deck. Is it contained in the list? Let's say. If it's true, then return the empty string, which is nothing. There's not even a space. And then it says in the list. So if red was in the list, it would say red is in the list. However, if it's false, if red's not in the list, it would add not, right, to this string. So it would say red is not in the list, right, if it was false. And this one line here does the horsepower of 3 lines or 9 lines, let's say. If, else, right? And a bunch of curly braces. All right? So that's what this ternary operator does. Then we add 3 more items, 1, 2, 3. What's the list count? I'm sure you've lost count because I have, right? Oh, okay. So here's what happens. So here's the first one. So before adding 2 items, count is 0, capacity is 0. Remember we said capacity is 2? No. After adding 2 elements, count is 2, capacity is 4. I have 4. I can hold up to 4, right? And then I loop through. I add a yellow and red, right? And then I add 2 more elements. Here's something that's weird. I would have expected capacity to be 8 right now, but it doesn't happen until my count is 5. Okay, so there's some interesting ways that capacity doubles sometimes, right? And it's good to understand when it happens. Look, I've got 3 extra elements here, capacity 8, count 5, that I'm not using. So that means like in the background, what I've really got is an array of 8 elements with 3 of the elements that are blank. That's what I got, right? And that's why lists, my friends, are less efficient, but more friendly to use than arrays. Okay? Yes? No, did you see that? Yeah, I went 0 to 4. All right, let's keep going. So I talked about all this stuff, the inserting and how it works. I'm not going to re-talk about all this stuff. Remove at, we talked about how that works, a specific index, right? And contains checks to see if an item exists, right? Where I want to really shuffle to, I'm going to kind of skip all this part to get to it. I want to go to this part. We talked about this last day, which is that LINQ uses something called deferred execution. Part of your Lab 25 today is to use LINQ, right? Because I'm going to get you to use it. So it's not going to be, the query is not going to be executed until you use it, until you access the results. That's what it means, okay? That's what deferred execution means. Even though you code up the query, you never use it, it's not really executing yet, okay? And then sometimes it's valuable to cast the result of a query as an array or as a list. And we're going to do that when we go into LINQ, when we use LINQ in our user interfaces. But we use toList all the time, and I'll tell you why. So let's say I'm reading a database. Am I getting a list from the database, or am I getting records from the database? Records, right? Records aren't lists. Records are records. But I can convert those records into a list, and then I can do that with my toList method, right? And we use var, the var keyword, because we don't know what we're going to get back. What if we're going to get a really different kind of variable back? var will kind of implicitly create the type that we need when we're returning stuff from a database, which is interesting. So we use toList a lot. Sometimes we use toArray as well if you want to have a smaller structure, but typically we use toList. And that's really all I want to talk about. The other thing that for list is the initializer syntax. So instead of me creating a new list with open bracket, close bracket, as an example, right? I can also add this in here. So basically says that, hey, put 4 elements into the list by default, these 4, right? When I'm instantiating the list object, right? Is that clear? So that's similar to what we do with arrays, but it's not exactly the same. Okay, so I wanted to point this out to you that does exist, right? The other thing is if I want to set up the capacity, when I declare the list in the first place, when I first start declaring the list, and I think it was up here, right? So here, this new list here, see these open bracket, close bracket? I could put a capacity in there. So I could say, hey, make a new list, and inside the open bracket, close bracket, I could say 52. So now I only have 52, a capacity of 52 for the list. I could do that, okay? And that's useful if you know the size of your list. But if you know the size of your list, sometimes it's better to use an array, right? It's faster, it's leaner, but it doesn't have as much control. You almost have, if you're doing removes and adds and inserts, then in your mind you might want to think about using a list because it's already been written for you. If you got to make your own inserts and removes and stuff, sometimes it's less efficient because this other stuff, and the one good thing about using lists and collections is that has been tested by professional developers. They know how to write code, and they've written it the most effective way they can. If you try and write your own add and remove and stuff like that, it might be not as effective, and you're recreating the wheel. So if you're going to do adds and removes, use a list. If you're going to use an array for holding data, don't use a list because it doesn't make any sense. Okay? If you know if it's a fixed array of a certain value for a certain amount. Okay. Any questions around lists and collections. We talked about a little bit lists, and we actually implemented it when we created our deck. But now, my friends, we have a problem. Okay, I'm going to leave this up for a second so we can visualize. I want to open up the project from the other day, right? I have my lesson 11B. By the way, yours is slightly different than 11A. And for those people who were in this section 1 class, I explained that. I said, look, 11A is slightly different because we did some refactoring with 11B to make it more efficient and all this kind of stuff. But one thing you notice is, look, if I'm going to add a hand, and in your lab 25, I ask you to make a hand class, or I ask you to use the hand class. I want to make a hand class, but a hand is a list of cards. And you know what? There might be some duplication between what I'm doing with my deck and what I'm doing with my hand, right? Which means I need a new abstract class called card list. Now hear me out. Will I ever instantiate card list? No, but it's a great blueprint for other lists, right? Other kinds of structures. And that's why I would make it. I'm doing it backwards to show you the value of using it first, if we had it already, all right? Let's show you how this works. So I'm going to make a new, let's do this together. So if I'm starting off with lesson 11B from last day. I'm right-clicking, and I'm adding, and instead of adding a class, I'm going to add this time an abstract class, okay, by default. I'm going to call this class card list. Okay, here's the abstract class card list. I'm going to put it in a different order because in my diagram, it makes sense that my card list is first, and then my deck is down here, right? And then maybe I'll have my hand over here. Hand is another type of card list, different than deck. We'll prove that. Okay, what can I do with my abstract card list, though? First of all, because I'm making this anew, I need some stuff, right? Let's take a look at my Solution Explorer here for a second, right? I know that in my program class, I have a good example of my comments, right? I'm going to copy the comments and go into card list because it's how I start all of my new files, right? And put the comments in there. So today is July 27th, right? And this is not a demo. This is the abstract superclass card list, right? And that's what we're going to do here. One, which is created the card list abstract class. That's what we're doing here, right? And now let's think about all the stuff that I would do in my card. It doesn't matter what class I'm creating, right? I should still start with the comments. So private instance variables. You guys should know what I'm doing here. Private instance variables, right? I'm going to have my public properties. I had a question earlier today. Why do I need public properties? Why not just make everything, and private instance variables? Earlier this semester, we were taught that Professor Render used private setters and public getters. Is that okay? Well, it can be, but I'm asking you to do differently. Remember, this kind of supports the whole idea of information hiding, where I'm storing my data in my private instance variables, and I'm accessing them with my public properties, all right? It's better, instead of using a private setter, right? It's better to not have a setter at all and make it a read-only variable, and then use some other kind of methods to access things internally. But again, there's multiple ways of solutioning, right? Here's my constructors. Here's my private methods. Here's my public methods. I'm just scaffolding out my structure. And this is really good practice for you guys. You should always kind of comment out this first so you know where everything is going to go. And if everyone does that in your team, you're working with a team of people and they all do that, then you know where to look, right? You know where everything is going to be declared. The best practice is to always declare your variables, even though they don't have to be, at the top of your code, okay? Then do your constructor, then do your methods. That's the best practice, right? Do you have to? No, C# will move things around and make things work anyway, but it doesn't make any sense. Okay, so cool. So I've got this little map here. I want to do my private instance variables. Well, for now, let's leave those alone, and let's start looking at my deck class to see what I can remove. So here's my deck class, right? And do I need my random? Am I going to do anything random with my card list? No, so I don't need that. How about this random property for my card list? No, I don't need that. And I don't need this for my hand either. I'm not going to randomize my hand, right? Like shuffle my hand. I'm not going to do that, right? Typically. So I don't need these things inside my abstract superclass, right? How about this? My constructor. Look, I'm calling the initializer. Okay, I need this. However, my initialize method in my hand, which includes the shuffling, will not be the same as my initialize method in my deck. My deck needs the shuffling, my hand does not, right? So I need the initialize method, but they're got to be different. Uh-oh. In my mind, I'm thinking abstract method, right? I need an abstract method called initialize that must be overridden, right, inside my abstract class. Let's do it. So I need this. First of all, I need this thing right here, right? So I'm going to take this, copy it. I'm going to go into my card list superclass, and under my constructors, I'm going to pop that in, right? All right, now this is a problem, right? It's not deck, it's card list. Here we go. And now it's saying, hey, I don't have an initializer. It's going to be private, or can it be private? So here's what I want to do. I want to make a private method signature that is abstract. That's what I want to do. And I want to call it, it's going to return void, and it's going to be called _initialize, right? Okay, but here's the problem. Why am I getting an error? Because abstract members can't be private. What would be the best fit here? Can't be public. Public is out. Remember, I told you to use this sparingly. What did I say to use sparingly? Protected, right? So this is a good match for protected. I'm never going to use it necessarily, but I need to have access to it inside my subclass. So I'm going to do protected here. Why is this going to work properly? Why? Because what's going to happen is I'm going to call this initializer method from inside my constructor, right? By default. So every time when I inherit from this abstract superclass, my constructor by default will create or call my initializer method. So the initializer method must be there to call, which means it needs to be overwritten. It has to be. I'm forcing it to happen here. Okay? Now I'm putting it inside private methods. Private or protected, they're kind of the same. They're private for the class itself. That's what protected is. Protected is private instance variables or private methods that belong inside, that they can access from the class or its children. Okay? So we don't want to use it too often, but this is a good use of it. Okay, so cool. So we've got this piece. I think this is a good addition. All right, let's take a look at the deck. What else can we drag from there? How about the toString method? Should I put that in there? Is my deck toString method going to be different in some ways than my hand? Maybe. If not, if it's just like this exactly, then I can take this whole method and put it inside my superclass, right? Because it's going to print out all the cards. Now, in the morning class, I didn't do that, and I'm not going to do that here. I'm just going to refactor this thing to make it different. So for now, I'm not going to put this in. Shuffle method. Should I put that in the superclass? So should all card lists be able to shuffle themselves? The answer is no, right? A deck can, but a hand shouldn't be able to, right? So the answer is this would stay. This would not go to my superclass. All right, cool. So I've created my superclass. Here's my card list superclass. So far, I have just this. It's pretty lean. Let's take a look what it looks like here, my card list, right? It looks pretty lean here. But what I want is for this to implement or extend this. So what I need to do is go back to my deck, right? And I'm going to refactor this thing. So I'll say 0.4, refactored to extend the card list abstract class. That's what I want to do. And now it doesn't inherit from the list generic type. It inherits from the card list abstract class. Right? Well, to do that over here where it says list card, right? Just like I have my card list here, right? So far it doesn't extend the list card. Let's do that. So I'll say this one has to do that. So I'll say list card. This is inside my card list, right? And now it makes sense, right? Card list, and I called it card list, right? That is more reasonable, right? And then with my deck, instead of extending card list, I'm going to, or extending list of card, I'm going to extend card list. Now it's going to give me an error. right? Because I haven't implemented the initialize method properly, right? I have an initialize method, but my initialize method, see the underscore that's green? It says your initialize method hides the implementation of the default method initialize, right? I don't want this. I want to do override, right? But the problem is that I can't override a method and make it private. If my superclass method is bigger, protected, I can't make it smaller in my subclass. My subclass's accessors have to be as big or bigger, which means it must be protected by minimum, at the minimum. And this is where I say use sparingly, because see how it rolls? That means now I've opened it up a little bit, even to subclasses of the deck class, if we ever do that. Okay, cool. So this is protected, right? It's protecting, it's get this initializer method, which satisfies my requirements here from my card list. So that's the only change we made so far. But here's another thing. Question, do we need my deck constructor? Well, it calls the initialize method. I could. That's an override. This overrides the default constructor. But I already do that here, right? So do I have to do it again? No is the answer, which means I can take it out. So I can take out the default constructor for the deck because it's already being done in my superclass. Okay? That's how I refactored. Right? So I refactored to extend the card list abstract class. I could put more detail in here. I'm not going to. And here's my card list, which only does this right now. Right? That's all it does. It doesn't do anything else. Right? And in my class diagram, it looks like this now, right? It looks like my card list, my deck extends the card list. That's what it does, right? Which it does right now. Okay, we made a lot of changes before we put it up on GitHub. I want to test my new deck because I've refactored it to see that nothing broke. So I'm going to go Control F5, right? And if everything goes well, then we're good to go, right? Here's my stuff. Now, see this part here? I put this in the program. And what I'm going to do is I'm going to take some of this out and put it inside the deck itself in the card. So I can make my toString method a little different. So what that means is, first of all, let me put this up on GitHub for you. I'm going to go to my Solution Explorer here. I'm going to go to Team, and I'm going to go to Home, Changes. And as you can see, I've changed my deck, right? And I've added a new card list. See the add there? So I'm going to say added card list abstract class. All right, that's what I've done. I'm going to commit. I'm going to go home. I'm going to go sync. And I'm going to go push. And that's going to push everything up to GitHub for you in a lesson 11B, so you can see what I did, just in case you didn't do what I did. OK, cool. So we've got this happening, right? We've got the deck class. We've got the card list. Deck extends card list now, which is cool. Now this is a great opportunity for me to add some functionality into my toString method. So here's my toString method, right? And what I did in my program is, down in my program, I added this extra stuff, right? But I'm figuring this should be part of my deck, or my toString method. So I'm going to take this stuff, right? This console. I'm going to copy it or cut it. Let's cut it out, right? I'm going to go back to my deck, right? Here's my deck. And inside my toString method, which is right here, I want to kind of put this in here. But it's not going to be console writes. It's not going to be this, right? I want to add this to the output string. So output string then, right, is plus equals to this, right? Plus, not deck count, but this count, right? And then plus a \n, here, I'll make it bigger for you guys to see this, a \n for the new line character. I need to do that too, right? Because if I don't do that, then there's no return character. That's cool, right? And instead of original deck, right, which is what I want to say deck contains, and then the number of cards, whatever the number of cards is. All right, now this is not good. I want to do the same thing here. So I'm going to say output string. You can see what I'm going to do here. Right, is plus equals to this as I'm building this up. And I'm going to put a \n in here, right? So this is going to add my functionality that I want, right? So I don't have to do that stuff in my program. All right, guess what it says? Deck. I'm going to do the exact same thing. I'm going to change this to hand, right? So that we know there's a difference. Otherwise, if I wanted to put deck and hand anyway, and I wanted to put this whole toString method in my abstract superclass, I could, but I would have to get type. So I would have to say something like this. Instead of deck, it would say get type this, right? And I would do some filtering, and it would come up with the same thing. Okay, I can show that it's a deck, or I can show that it's a hand, right? For now, I'm going to leave it like this so I won't confuse you, but it can be done if you really want to. If you want to explore that, you can go into your card list superclass and make the toString method, and both the deck and the new hand class that I'm going to create will inherit from it. Okay, so this, I'm going to go back up here. I did change something. So I'm going to go here in 0.5. I'm going to say I refactored my toString method. I always call. Refactored the toString method. Include a header. That's what I've done, right? And of course, I'm going to go to my Team Explorer. I'm going to go to Home. I'm going to go to Changes, right? And I'm going to say, I'm going to do the same thing, refactored a toString method to include a header in the deck class. Okay, commit. Home, sync, and push. So now you have everything. Okay, cool. I'm ready to make my new hand class now, right? Again, remember what I want to try and do. What am I simulating? Right? Well, I'm simulating this. I've got my deck. I want to make the ability for me to have a container that contains a hand of cards. I'm just using our friendly Google here to give some visuals, right? But let's take a look at that. So I'm going to go back up here. And what I want to do in my class diagram, again, I want to use my class diagram to do this. I'm going to right-click here, add a new class. And I'm going to call this the hand class. Here's my hand class. Yay. Is there other ways to do this? Absolutely. But one thing I want to do is I want to inherit from the card list superclass, right? So I'm going to double click. I'm going to go to the top. And I'm going to say, well, it inherits from card list, just like my deck does, right? But here I can hover in, and I can kind of do one of these and implement my abstract class, my initializer, right? By default. Because it's abstract, it creates it right away. Let's add some defaults here for comments. I want to do the same thing. To be smart, because I know I'm going to do this, I'm going to go to my card list. I've got some default comments right here. Instead of copying, writing them out, I'm just going to go copy, go to my hand, paste, right, from my constructors. And then I can add in my other stuff, right? If I really want to really be lazy, I can do that too. But here's my private or protected methods, right? And I have maybe a public method, which I'm going to make the toString method. And you know what? I might as well copy the deck toString method for now, which is right here with all of its lovely comments, and modify it a little bit. Just to show you that there is an opportunity here. We have an opportunity to make this a custom or an abstract method by adding this to the abstract superclass card list. But you have to do something with this. Instead of deck here, we want to have C hand. That's the only difference. I changed deck to hand. Okay, at the top, we're missing a header. If I'm going to go to the deck, I'm going to go to my deck here, and I'm going to copy this header, right? And I'm going to go back to hand. And at the top, I'm going to put a header in here, right? Because I want you guys to all do the header stuff. And this is 27. This is the hand class. It inherits from the card list abstract class. That's true. And this is where I'm creating it. So created hand class. And so far, we're golden, right? That's all it does. So it initializes, but the initializer is not implemented. Hey, question. If I instantiate an object of type hand, right, what will happen at this point? Well, the constructor, I'll answer my own question because no one's offering their answer, right? The constructor from the superclass is going to trigger, right? because my superclass constructor always triggers when I call a subclass of it, right? That's number one. And if it triggers, it's going to call the initialize method. But my initialize method has this inside of it. So what's going to happen? I'm going to get an exception, right? So I need to get rid of this. And for now, I'm just going to put in an empty method. We don't need it yet. But I'm going to put in this method is empty, right? I could put in also, a lot of times what I like to put in here is stub, right? Because it means that this is just a placeholder right now. We need it because my abstract superclass requires it, but I don't need it yet. I'm not initializing anything yet, right? But it's required. So I leave it in. Okay? Is it good? It's good if I'm going to use it. That's the answer. Okay, cool. So I've got this toString method. I've got my empty initializer method that I've made it. I called it a stub, right? Hey, guess what? I've got my hand class. And if I look at my class diagram, you can see the relationships now, right? A hand is a card list, but it is not a deck. They are siblings. They're like each other. A deck has some other stuff. The hand class does not. And I'm going to make the hand class have some stuff later on that the deck is not going to have. That's part of your lab 25. Okay? All right, so we've got our little class diagram here. We've got our card list, right? Let's make a new method, but before I do that, I'm going to put up everything that I have up to GitHub so you guys are up to date with me. So I'm going to go to Home, Changes. You notice that I have my hand. I'm going to say created a hand class, right? And I'm going to go home, sync, and push just in case you couldn't do what I did. All right, so that's up and live right now. You can check that out. Okay, cool. Well, here's what I want to do in my card simulation, because that's what we're really doing here, right? I want to, or this card game simulation, more of this. I want to be able to deal one card. And when I say deal, for those people who don't know what it means that I take the top card off of my deck, the top card, and I remove it. Okay, I'm removing at 0. That's what I'm doing. But remove at actually deletes that element. I have to be able to save it somehow, right? I have to be able to put that somewhere, okay? So if I create a new method that's part of my deck class called deal1, my deck should be able to deal, right? Not my hand. My hand doesn't deal anything. Well, maybe it does if I'm holding my deck. But in this analogy, the answer is no, it doesn't deal. The hand receives cards from the deck, right? The deck deals cards, right? I can deal cards or shuffle cards, right? So I want to be able to create a method called deal1, which only deals one card. It takes a card from the deck and returns a card object. That's what it does. How do I code that? So in my deck, I'm going to say 6. Notice how I'm doing this beforehand. Added the deal1 method, right? I'm going to go down to public. It's going to be a public method, right? I messed up this morning. I instead of putting it in my my deck class, I put it in my hand class first by accident, and then I had to refactor because I forgot what I was doing. But we're not going to do that error here, right? So I'm going to say public, right? It's going to return, my deal1 is going to return a card, right? Because I'm returning a card. That's what I want, right? And then when it returns a card, I want to call it deal1. I could have called it deal1 as in O-N-E, but I'm just going to use the number here just to demonstrate that I can. It's not going to take any, it's not going to take any objects, but I need to return a card. Okay, cool. So step 1. Let's scaffold this out. I always start like this. I'm thinking, okay, what do I need to do? I need to remove an element from the list, right? So let's put that in there. So I'm going to say this, which is the list itself, right? Remove at, and then 0. But remember what this does. This removes the top card from the deck. That's what it does, right? It removes it. Poof, it's gone. It's into the bit bucket in the sky if I do that, right? I've got to be able to read the first card, the 0th card somehow, right? Well, I have a method for that. Remember, we made the card itself has its own clone method that we wrote with the iClonable interface, right? So I can clone the card and return it. But I need a temporary placeholder. So I'm going to call this, right? I can call it temp card, or the card that's been dealt, right? I'm just going to call this the top card. It's a type card, right? Because that's descriptive, right? Top card. And notice that I can do this in one line or two lines, but for now, just to save space, I'm going to do it in one line. I can say top card is equal to this at element 0, right? And that is the top card, yeah? Wouldn't it be? Because my deck is a list, right, like before, then element 0 is the first card, the top card of the deck. So I'm taking that top card of the deck, and I'm assigning it to top card. Then I'm removing it, and then I'm going to return the first card, this 0th card, out. So the next line is return top card. Does anyone not get this? When I deal a card, actually I'm taking the top card of my deck and I'm taking it off. I'm removing it. Poof. But it's got to go somewhere, right? It's going to go into my hand. That's where it's going to go. Or on the table. In real life, it would go on the table, right? But in what we're doing here is it's going to my hand. I'm just taking it from the top of the card, the top of the deck. Okay? So here it is, the top card, I'm returning the card. And this is what this little thing does. So let's just comment it. So this method returns the top card of the deck. Okay? And just kill this. We don't need that. We just kind of explain that. Okay, guess what I did? I added the deal1 method. I coded it down here. And now I'm going to put it up on GitHub. So I'm going to go to Home, Changes, and I'll say added deal1 method to the deck class. Okay, commit all, home, sync, and push. Okay, you got it? Now, I need to test it. So let's go in my program class, and I'll say 04 tested new deck class. Notice that my program driver class is my test harness, right? I keep on testing stuff in here. One of the questions I got from this morning's class is, Tom, you didn't ask us to do testing of the moons and everything else for assignment number 4. What do you expect from us? I expect you to make your own test harness is the answer, right? You make your own test harness to test your class, right? Could I make you do it? Sure, I could, right? And someone said, well, what if I put a lot of stuff in there? Would you get mad if I put extra stuff in there to test my code? Why would I get mad? It's you're testing your code. That's a good thing, right? And the other question I asked was, what if you created a separate project, a test project? You were all taught how to do testing, right, with Professor Narendra. What if you created a separate project for testing your assignment? Is that bad? Am I going to take marks off? Oh my God, they created a test project. Let's give them 0. Hell no. I think it's a great thing to do, right? I'm not going to do it. You need to do it. This is your project. You need to test it. You need to create all the tools. You need to use all the tools at your disposal to make sure you test it, because guess what I'm going to be doing? I'll try and break your project. I'm going to try and make sure that whatever I can do, I'm going to try and break your project, right? As much as possible. So you want to try and make it foolproof. Now, there's not a lot to test in this particular case. Your project, your little assignment is quite easy, right? If you don't think it's easy, that might be a problem, right? All right, so cool. I don't care about the shuffled deck. I could put this shuffled deck of cards in here. But what I really wanted to do was just shuffle it and then kind of create a console write again. That's what I really wanted to do, and print it out again. That's my shuffled. I could put a little comment in here, like shuffled. Right? I could do that. Because really what I'm doing is I'm shuffling the deck. I make a new write line. I'm shuffling it. I have the two-string method, and I've got my deck shuffle. Okay, cool. Now this is what I want to do. I want to test out my hand, right? But I need a hand object. So I'm going to declare it here. I'm going to say hand is equal to a new hand. And what this does is it'll create a new hand object. It's a type of card list but it's different than the deck class. Okay? All right, so let's try it out. I want to do this. I want to say hand. Well, what I want to do is I want to add to my hand. I'm adding to my hand. And I want to use the new deck method, deal1, like this. Deck.deal1, and that would add it into my hand. How come this works? Right? How come this works? When I add something to my hand, it's going to add it in there. Now, I want some feedback to know what my hand contains. So for now, and only for feedback purposes, inside of my deck class, where I have this, I want to show the value. And this is just before I return. I want to show the value of my stuff. So this is for testing only, right, which I'm going to return, or debugging. And I would take these comments out later on. So when I go through, I might have debugging steps like this, but then take them out after, right? So for debugging only, I'm going to do a console write line. And inside my console write line, I'm going to do something like this. Okay? I want to show the size of my deck after I remove something, right? So here's my remove. I remove the card, right? Or I'll say dealt one card, right? Size of deck is this dot count, right? And I want to do this because every time I deal a card, I want to know what my size of my deck is. So when I deal my first card, the size of my deck is 51. If I deal it again, size of my deck is 50, 49, 48. Every time I deal a card, the size of my deck will go down. Okay? That's what I want you to think about. All right, let's check this out now. I'm going to deal my hand, and what I want to also do is I want to show my hand. I'm going to say hand.toString. Show me my hand after I dealt my card. Deck, its own list. Hand, another type of list, both card lists. I'm passing one value to the other list, from one list to the other. Okay? Very straightforward. And let's try and run it and see what happens. Okay, there we go. So dealt one card, size of deck 51. That's a new size. Hand contains number of cards, 1, right? The ace of clubs is what I did. That's a pretty good card. Ace of clubs, right? And if you notice, right, I started off with 52 cards in my deck. My ace of club was the top card. I dealt from the top of my card, which means now the top of my list should be the 2 of spades. To check that, let's do a further test, right? And down in here, I'll do another console write line, right? Oops. I'll just print that out again. This is my test harness, right? And I'm writing it out. So now I'm going to do a console write line, and I'm going to say deck.toString again, right? Okay, let's try it out again. Control F5. And you can see that now, originally I had 52 cards. The top of my deck was a jack of spades. That was randomly generated, right? Because I shuffled my deck. So then when I dealt my card, the jack of spades went into my hand, right? And now the 6 of spades is the top of the deck. And if I look at the top of the deck, the 6 of spades should be the top of the deck because I dealt the top card. I removed it. Okay, let's do one more further example before I continue. What if, instead of hand 1, I deal 2? So I'm going to do this thing a couple times. So let's do this. And I do this, right? And I'll do a little console write line in the middle, just give me a little bit of space. What does it do now, right? Well, this is a good test, right? It does this. So initial deck was like this. That's my shuffle deck. The 7 of spades and the king of clubs were the top 2 cards. I dealt 1. My hand has now the 7 of spades. I dealt another one. My hand contains 2 cards now, the 7 of spades and the king of clubs. and the next card on the top of the deck is the ace of diamonds. All right? Anyone have any questions around how that works? Right? This is a good example about how lists are manipulated, right, from the top. One person asked me again, I have to say that I'm going to put this up on GitHub now, right, so you guys have it. Actually, before I do that, I'm going to add one more thing. So think about what I'm doing, what I want to ask you to do on your lab. Let's take a look at lab 25. So what I'm asking you to do is, using the deck, I know it's hard to see here, guys, and I apologize. Let's see if I can make this a little bigger for the people at home. There we go. Using the deck and hand classes that we built together in class, create a method named deal5 that deals 5 cards from the top of the deck, starting with element 0. The cards will be removed from the deck container, right? The method will return a new hand object, not a card, right? Why? So imagine I have nothing in my hand, and I deal 5 cards, and now I have a whole hand of 5 cards, right? That's deal 5. Typically, no one deals 5 cards to somebody as part of the game. It's usually the beginning, right, where I get 5 cards. And then I can deal 1 at a time, right? I can also do other things in my hand. For example, in a regular game, I could remove cards. I can drop a card and pick up another card from the deck, right? But for now, all we care about is creating this new deal5 method. This is worth 2 points. To create the deal5 method that basically returns a new hand object that includes these cards, these 5 cards. So that's the first objective. One thing to do is create a deal5 method in your deck class. Okay, cool. Next, using link. This is your opportunity to use link. Create a method named highest cards in the hand class that identifies, actually, yes, in the hand class, that identifies the most valuable cards in the hand object. So what am I doing? From card in this, where card is greater than some value. I don't know what you want to, how you want to do this, right? Select card, right? And I'm going to do that, right, for the top cards. I want to get a collection of cards that match certain things. So you have to figure that out, okay? The highest cards. And there's different ways of doing that, okay? Test these new methods in the driver class program by first calling the deal5 method of the deck object and assigning them to the hand object. I'm going to give you this piece right here, right now, to understand what I mean. Okay, I'm going to do this right now for you. Okay, use the overridden toString method of the hand class, which we already have, right, to display the current cards contained in the hand to the console. I've already shown you how to do that, right? Then call the highest cards method of the hand object to display the highest cards of the hand to the console. Ensure that you use GitHub for 2 points. This is worth 10 points, but 0.5%, 0.5%. It's a good test for you. Please, I want a zip archive. If you give me a raw archive, you're going to lose a point, right? And a link to your GitHub. By now, you should all have a link to your GitHub because tomorrow your assignment 4 is due, and you should all know how to use Git and GitHub. If you don't know how to use Git and GitHub, you're going to use 4 marks off the top for your assignment number 4, guaranteed. Or if you just put it as backup, you'll lose 2 marks off your assignment. Either way, you're losing marks. And you're going to lose marks and marks, like I said, and you're going to keep losing marks until the end of semester, right? Until you figure out how to use GitHub. You need to learn how to do this. So don't avoid it, okay? Any questions around Lab 25? It's posted on eCentennial. It's due by tonight at midnight, right? We can do some of this in class right now. But before we get there, I want to give you a little bit of a boost to start. And I want you to think about what I mean here. Right now, what I have here is this new deck, right? But really, this new hand is going to be overwritten, right? Because what I really want to do is if my new deal5 method in the deck class returns a hand, then all I should do is something like this, right? My hand is equal to, right, this is the pseudocode, if you will, right, is equal to the deck dot deal5, right? And what this will do is it'll assign, whatever deck we create with the deal5 method, right, I'll assign it to hand. Okay? So moves the top 5 cards of the deck to the hand object. That's what it does. Okay? So that's all I want you to do. That's that one part. So you need to do this. Okay. One question I had earlier, I'm going to put this up on GitHub now for you, so you have all this. So I'm going to go home, changes. I modified my deck, right, to include the hand or deal 1, right? So added deal 1 method to the deck class. That's what I did, right? Commit all, home, sync, and push. So you should have all that now. Okay. So one of the questions I had earlier, there's a couple questions, right? One was, hey, can I, in my deck class, because I have the deal 1 method, could I call the deal 1 method from the deal 5 method? Yeah. Why do you think I made it? Right? Why not use something that's already been done for you? That's the question. Could you make it more effective? And one person says, well, isn't it going to print out the cards every time you deal something? Yeah, but this is for testing only. That's why I put for testing and debugging only, right? You want to take this out now. You don't need this. This is just to check to see what's happening in the background. But I don't really need to know yet, right? In fact, your whole program class is, I'm using it for testing and debugging to build up all of my classes and objects so I know that they all work, right? But you can also use a test project of your own to do that. Okay. Are we clear on the requirements for the deck and the hand? So deck is going to need a new class, a new method, sorry, called deal 5. And hand is going to need a new method called highest card or highest cards, right? I don't know what I called it, right? Which is going to return the or output the 5 highest cards or whatever, however many highest cards are in your deck. Right? So here's the question that I got earlier. What if I have 5 cards, right? How do I know which is the highest? Well, it's done by face value, right? So if the face is king, that's the highest card. What if you have 2 kings? Well, they're equal, so both of them get printed out. What if you have 3 kings? Well, then all 3 of them get put out. What if you have 1 king and an ace? Ace is 1 in this scenario, and a king is 14 or whatever it is, right? Or 13. So only the king is going to print out, but not the ace. Ace in our case, in our card game, is 1. Is worth 1, right? In other card games, it's worth 14. Right? Okay, here's the other question. Highest values, right? What if I have 2 10s and a king, right? Well, the king is going to print out. The 2 10s are not. What if I have 2 10s, a 9, an 8, and a 7? The 2 10s are going to print out, right? Because the 2 10s are the highest, right? So whatever the highest card is, whatever the highest value is, you got to figure that out first. Number one, what's the highest value? You have to figure that out. How do I do that? I can sort my cards, right? I'm telling you in advance. I can sort my cards from lowest to highest. If I look at the top of the card, right, I know what I'm looking at, right? Or the lowest card, I automatically know what I'm looking at, right? So I can find out what the highest cards are, well, how many cards I have. I'm going to use link, though, right? I'm going to use link, and I'm going to basically do a where statement where the cards are the highest cards in the deck, right? There's other ways to do it with a for loop. You can search through with a for loop and do it, but I want you to try and use link, and that's worth 2 points. If you use a for loop, you'll lose a point. Okay? Suit has nothing to do with it. Who cares about suit? Suit, they're all the same. One suit isn't greater than another suit. So not really, not really. It's kind of the aces, but the spades is probably the highest. But for now, we don't care about that in our card game. There's no value. Each suit is the same value. So all I care about is the face value. Okay, any other questions about Lab 25? All right, so I'm going to stop recording here. I'm going to give you, for the rest of the class today, a chance to work on your lab. And any questions you have on assignment 4, I'm here for you for today. And then remember, assignment 4 is due tomorrow night at midnight, and your lab is due tonight at midnight. Okay? So that's it for me today.